All right, so I'd like to start with discussing some problem solving tips. So this is a physics course. You're going to be solving a lot of word problems, if you will, that you would call them in a math class. So how do we go about solving these types of problems? Well, there's sort of a general step-by-step method that's useful when trying to figure out how to solve these physics problems. These problems are designed, of course, to use the information you were just taught in that section, apply that information to solve the problems, and at the end of the chapter, those problems address concepts you learned in that chapter. So you're not going to go out of left field and suddenly talk about nuclear physics problems in a chapter on fluids, right? So physics does build on itself, of course, so you may see these constant acceleration problems later on in the semester, but you'll have those tools and build off those tools as we progress. So problem-solving tips for one-dimensional kinematics problems. The first is examine the situation. What physical principles are involved? Does it talk about friction? If it talks about friction, then it might be a friction problem, and you have to apply friction principles, which we'll learn later. Is it a free-fall problem? We'll talk about free-fall problems in the next video. Is it a problem dealing with motion, kinematics, acceleration of velocity? Is it a problem dealing with density? Is it a problem dealing with charge, magnetic fields, whatever? Identify what type of problem it is so you know what types of equations you need to use. Of course, on exams, I'm going to be testing you on the final exam. I'll be testing you on the material from the entire semester. So point number one is very important. When you look for those equations that you need to solve my final exam problems, you're going to need to know, is this a friction problem? Is this a orbit problem? Is this a problem with free fall gravity? Is this a problem with dealing with simple kinematics or circular motion or whatever? The second is just identify the knowns that are given or inferred from the problem. So sometimes it says, at time t 2 seconds, this happens. Or with an initial velocity of so many meters per second, a car starts to accelerate. Write down what those knowns are. Identify them, right? Do you know the initial velocity? Do you know the acceleration? Do you know the time? Do you know the initial position? Do you know the final position? What do you know? Do you know the average velocity, the final velocity, initial velocity, and so on? What do you know, or what can you infer from the problem? Write down those values. Now, what do I mean by infer? Well, sometimes your textbook might be a bit vague and will say, starting from rest, a car will accelerate. So it doesn't explicitly tell you the initial velocity is 0, but if a car is at rest, its initial velocity is 0. It can also help, a little bit with step 1 again, and step 2, it can also help to draw out the problem. Draw out the object that's falling, or the car that's moving, or the ropes that are pulling on some box, to give you an idea of what's going on. Third, identify what needs to be determined from the problem. Now, some of these problems are multi-step problems. So start with step 1, step A. What do you need to know? Are you trying to solve for the acceleration? Are you trying to solve for the time? Are you trying to solve for the displacement, or the final velocity, or the initial velocity, or whatever? Write down those unknowns. Once you know what you need, say time, you're solving for the time, and you know what you have, say acceleration and initial and final velocities, then find an equation that helps you solve that problem, that has those variables in it. Now, your unknown, in step 3, let's say it's time again, you have to have an equation that has time in it because you have to solve for time. Time is your unknown. So you cannot use an equation that doesn't have time in it. Right, the v squared is equal to v naught squared plus 2a times x minus the quantity x minus x naught. There's no time in that equation, so you couldn't use that equation to solve for time. Find an equation or equations, set of equations, that help you solve the problem. Once you have that, it's best algebraically to solve those equations for your unknown. A lot of people just plug in the numbers and then start to do the math that way. Algebraically and in physics, it's best to solve that problem algebraically and then plug in your knowns. So substitute the knowns into the equation with their units and obtain a solution with units. So this is very important. Don't just use the numbers. Make sure the units are included if they're not SI units. If you convert everything to SI, then you can kind of skip 5 a little bit if you're comfortable, because you'll know the units will work out because everything is in SI. Everything is in meters and seconds and kilograms and so on. And then finally, once you get a solution, that solution will most likely have units as well, right? How far is it to Merrill? It's this many meters, this many kilometers, this many miles, whatever. You have to use units. A number without a unit in physics is meaningless. Now, on a rare occasion, you won't have to deal with units. It might be, what is the ratio of this distance to that distance? Well, that's a unitless quantity. How many times further away is this object from that object? Or how many times longer does this reaction last versus that reaction? Those are unitless answers. But for the most part, most of your answers are going to need units. And then finally, check to see if your answer is reasonable. Now, some of the later physics problems you'll get, you will be dealing with accelerations or particles so small, there's no intuitive feel to what is an appropriate answer. But with one-dimensional kinematics, a lot of these problems, there is an intuitive feel, right? A car accelerates so fast for so long, how long does it take to get to the nearest town? If your answer is in milliseconds, well, cars don't travel between towns in milliseconds, so you probably made a mistake. If your answer is in centuries, you might have also made a mistake, right? If you're asked to solve for the weight of a person on a merry-go-round or a teeter-totter, and you end up that person's weight has to be 2 million tons, you've probably made an error. If you have made an error, go back and try to see where these errors might creep in. It's very hard sometimes to figure out your own work, your own mistakes. It's kind of like proofreading your own papers. But take it step by step. Maybe put the problem away for a few minutes or half an hour, work on something else, and come back. Problem-solving tips. Another one would be post on our discussion boards if you get stuck. But I expect you to have tried the problem first. All of these problems you should be able to solve on your own in an ideal situation. Now, even I sometimes will make simple mistakes on problems like this. So having a second pair of eyes to look over, or a second pair, an opinion saying, where do I start? I'm not quite sure what it's asking for in this problem. The wording is confusing. I'm happy to answer on the discussion boards, or other students. Hopefully you'll be checking those discussion boards and giving feedback to answer these problems. The only thing I ask is that you help a student with a problem like a spotter helps weightlifters. If you've ever been in weightlifting class or look at weightlifters, right, they're lifting a lot of heavy weights. If they're pushing about what they can conceivably push, sometimes they'll have a spotter to help them with that last rep, right, that last push. The spotter doesn't grab the bar and pull it from them and do the work, right? Doing 10, the spotter sits and curls 10 times, and then the person on the bench says, hey, I did 10 push, and I did 10 bench press. No, that's not how it works. Be like a spotter. Give them enough support so they can finish it on their own, but not enough that you complete the problem for them. So tips, tricks, say, hey, maybe you want to consider using this equation out of the book, or it looks like this example problem from the text, or, oh, did you convert units properly, and so on. Don't solve problems for them, because when the test comes, you're not going to be able to help them, and you need to be able to solve these problems in order to be successful on the test.